So in today's tutorial video, I want to look at statistical methods for analyzing two sample data in SPSS. But before we proceed, I'll urge you to kindly take a look at my previous tutorial video on the flowchart for classifying data, because in that video tutorial I illustrated and explained the data structure for two sample data, which will help you to catch up with everything that I'm going to do in today's tutorial video. Okay, you can just click on the link in the card above or check the link in the description of this video. Okay, so like the one sample data, we have parametric tests and non-parametric tests for analyzing such data. The same applies with two sample data. So the type of parametric test for two sample data is known as the independent T-test or the two sample T-test. This test basically compares the means of two separate groups to determine whether statistical evidence shows that the associated population means are significantly different. Okay, for example, researchers may wish to compare the mean income level of two regions or the mean effectiveness of two drugs. There are certain assumptions which must be satisfied before we can make use of this test. One of the assumptions is that the data must be continuous. The next one is that the two samples are independent. We also have this condition stating that the data must be normally distributed. And the last but not the least is that the variances of the two populations are equal. This condition is an asterisk because even if it is not satisfied, we can still proceed and make use of the two sample T-test. We just have to specify in our computation that the variances are not the same. Okay. Now let's take a look at the non-parametric test for two sample data. This is known as the Mann-Whitney U test or the Wilcoxon Rank Sum test. This test basically compares the medians of two separate groups to determine whether statistical evidence shows that the associated population medians are significantly different. Okay. For example, researchers may wish to compare the median income level of two regions or the median effectiveness of two drugs. There are certain conditions which must be satisfied before we can make use of this test. One of the assumptions or the condition is that the data must be continuous. The next one is that the two samples are independent, and the last but not the least is that the data must not be normally distributed. Okay, so now let's take an example. As a researcher, you wish to compare the average sepal length of the Setosa and Virginica plant from the iris dataset. Perform statistical analysis for this data. Okay, so before we jump into SPSS to begin, let's take a look at the iris dataset in a CSV format. This is a clean dataset, so before you analyze any dataset, you have to ensure that you have cleaned your data. So if you want to learn how to do data cleaning in SPSS, you can also take a look at my previous tutorial video on exploitative data analysis in SPSS. Okay, you can just click on the link in the card above or check the link in the description of this video. So the problem here is to basically get the sepal length for Setosa and that of the sepal length for Virginica and try to find out if this average value are the same or not. Okay, so the first thing that we are going to do is to filter the sepal length for Setosa, which starts from here and ends somewhere here. Yeah, I think it ends here. Now the end for Setosa. Then you also have to filter the sepal length for Virginica, which starts somewhere here. Yeah, 101, and it ends to the last one, of course. Yeah, so once we filter this, we have to find the average value for this sepal length for Virginica, and also do same for Setosa and try to find out if this average value are the same or not, or basically want to find out if the difference in the average value is equal to 0 or it is significantly different from 0. Okay, so let's jump into SPSS. Alright, so the first thing is to import our data set. So I'm going to use the open data document icon here. Click on this. Right, then the next thing is to navigate and check the folder where you have your data file. I have my data file in this folder, so I'm just going to the files of type and check all files. Okay, then this is the data. So I'm going to leave this data set in the description of this video so that you can download it. Okay, so just pick it and open. Alright, so there are some instructions that we are supposed to follow before we can finally view our data set. Okay, so in here we can skip this, right? So you can click on next. Alright, so at this session Are variable names included at the top of your file? If you look at the preview of your data set, you can see that the first row is made up of variable names, so we can check yes, right, and scroll down, next, finish. Okay, so this also comes with an output window where you can see the result from your analysis. Okay, so that's the output window where we will see most of the results from our analysis. Okay, let's go back to our window editor. Yep, so I think we have opened this. That's why we can't view the data set, so we have to close this because we have already opened it and Spss cannot read it. So let's close this, save. So I want to save it. Save, yeah. Yes. Alright, so once you close this, you can go back and let's import it again. So let me click on this. Yes. So let's navigate again. Open, yeah. So once you open the data file in a CSV format or in an Excel spreadsheet, if you don't close it before trying to import it in Spss, you may have this challenge. So you always have to close it before you start your importation. Okay. So let's continue next. In here we check yes. Yeah, we check yes, so we can proceed. And next, finish. Okay. Alright, so now we have finally import our data set. So let's try and get a structure for our data set. Let's go to variable view. Okay, so in here you can see that CPA length, CPA width, petal length, and petal width are all numeric, and species is string. Right, if you look at the scale of measurement, and this for our ratio scale, but this is nominal scale, right? So one thing that we have to do with regards to this nominal variable is that it's a type of categorical variable, so we are supposed to basically encode this by assigning values to the labels, okay, of the species. So in our data manipulation, that's the first thing that we want to start with. Let's go back to our data view, scroll up, and let's encode this species, right? If I click on the value labels, I don't see any changes, right? Anytime you have a categorical variable, you're supposed to encode it by assigning values to the labels, okay, of that variable. So that's basically what we want to start with before we proceed with other things. So let's click on transform, scroll down to automatic record. Yep. And then let's scroll down to species. Let's drop it inside this box. So let's click on this. Let's give it a new name. We don't want to override the previous name, so let's say species 1. Okay, then let's add new name. Okay, then let's scroll down to okay. So if you look at the result window, you can see that we have now assigned values to the labels. 1 has been assigned to Citosa, 2 has been assigned to Vesica, and 3 has been assigned to Virginica. So we are good to go. Let's go back to our window editor. Yes. So you can see now that once I click on the value labels, it will now change for this. Okay, so 1 has been assigned to Citosa. If you scroll down, you see that 2 has been assigned to Vesicolor and 3 to Virginica. Okay, so we are good to go now. So we can even drop this variable. Let me scroll up. We can drop this previous one, we don't need it anymore. So right click on that and clear. Alright, so we are good to go now. Now the next thing that we are supposed to do is to filter the CPA length for Citosa and that of Virginica. So let's go to data, scroll down to select cases, and let's try and use the if condition. So click on this. Okay, so let's drop the species inside the box. Yep, and let's pick the label 1. 1 is for that of Setosa. Let's use the OR operator, and let's drop the species again. This time we are interested in the label Virginica, which was assigned 3, so we are good to go now. Let's scroll down, continue. Alright, so with the output we have 3 options. We have one which is to filter out the unselected cases. We have another one to copy the selected cases to a new dataset, and the last one is delete unselected cases. Let's choose this one and click on OK to proceed. Alright, so let's go to our window editor. So let's scroll down and see. So we now have only that of the data for Setosa and that of Virginica. Okay, we don't have that of Vesicala in here. So basically we can ignore these variables. We don't need them, so let's highlight them, right click and clear, so that we get only the sepal length for Setosa and that of Virginica, which is only 98 observations now, right, instead of the previous 148. So we are good to go. Alright, so the next thing that we want to do is to basically do some exploitative analysis on this data set, so that we get to know whether we are going to make use of the 2-sample T-test or the Mann-Whitney U test, okay? But this will look similar to the one that we did under the statistical methods for analyzing 1-sample data in SPSS. So I don't want to repeat the same process, so I'm going to skip the exploitative analysis in this session, alright? If you want to learn how to do the exploitative analysis, you can check my video on statistical methods for analyzing 1-sample data in SPSS, okay? From the exploitative analysis, we got to know that the distribution of the sepal length for Setosa and that of Virginica were nearly symmetric, right? So I want to skip that part and proceed to the test of the assumptions, test the assumption under the 2-sample T-test, right? So we know that the first assumption states that the data must be continuous, right? So if you look at these values here, they are continuous, right, data. And the second assumption is that we have to check if the groups are independent, okay? That is, the samples must be independent, and this is a typical example of independent data because the sepal length for Setosa is different from the sepal length for Virginica. These are 2 different groups, so this makes it to be independent, okay? The occurrence for this value has no influence over the occurrence of this value, for instance, okay? So this makes it to be independent. These are 2 different groups altogether. Now the next assumption is to check for the normality, right, to ensure that the data is normally distributed. So that's basically what you're going to do now. So let's scroll down to analyze, scroll down to descriptive statistics, and let's check that off explore. Okay, so let's drop this sepal length variable inside the dependent list. So let's do that, and the species 1 should come under the factor list, okay? So let's check the options here, statistics. Okay, so let's close this plot. Let's uncheck this and check that on the normality plot with test. Let me scroll down to continue. Then options, we don't have to do much here, so let's close this. Then let's click on OK. So it's still running. Alright, so here we go now. So we have some descriptive statistics, right? This is similar to what we did under the statistical methods for analyzing one sample data in SPSS. I don't want to repeat this kind of descriptive statistics interpretation, so I'm just going to skip that and just proceed to the test of normality. In here, we are going to interpret that of the Shapiro-Wilk test. Okay, so this is the sepal length for Cetos and this is the sepal length for Virginica. Okay, and these are the p-values. These are the p-values, right? So the p-value for the sepal length for Cetos is 0.325 and that of Virginica is 0.253. Okay, the null hypothesis for the Shapiro-Wilk test states that the data is normally distributed. Okay, so we are going to reject the null hypothesis if this p-value is going to be less than or equal to the alpha level at 1% or 5%. Okay, now because these p-values are greater than the alpha level at 1% or 5%, it means that we fail to reject the null hypothesis and conclude that the distribution of the sepal length for Cetos and that of Virginica are normally distributed. Okay, another way to confirm the normality test is to make use of the QQ plot. Let's scroll down. Alright, so let me scroll down. Yep. So this is going to give us the QQ plot of the sepal length for Cetos. Alright, and the QQ plot, what it does is that it basically draws the correlation between a given sample and the normal distribution, right? Such that if the data is approximately normal, then the plot will closely resemble a straight line like this, right? Sloping upwards to the right. Okay, so this is an indication that the distribution of the sepal length for Cetos is normally distributed. If you scroll down, let me see, let's get that of the QQ plot of the sepal length for Virginica. So you can also see that in here the points are on the straight line, even though some seems to deviate from it. Majority of the points are on the straight line sloping upwards to the right. So this is an indication that the distribution of the sepal length for Virginica is also normally distributed. Okay. Alright, so now that we are clear that in our mind that the three assumptions have been satisfied, we can then proceed and make use of the two sample t-test or the independent t-test. So let's go back to our window editor. Okay, so now let's go to analyze, scroll down to compare means and scroll down to independent t-test. Okay, alright, so in here let's drop the sepal length variable inside this test variable box. So let's do that, and the species one should come under the grouping variable. Okay, so let's define the groups. We know that one was assigned for Cetosa, so let's put one here for group 1, and 3 was assigned to Virginica, so let's put 3 here. Okay, continue, and let's click on OK. Alright, so here we go. So if you look at this result, we have some group statistics. The mean value of the sepal length for Cetos and Virginica, here are they, and we want to find out if this mean value are the same or they are not. Okay, before we test the equality of means, we have to check for the last assumption. If you can recall, one of the assumptions under the two sample t-test states that the two population variances must be the same. Okay, and in here we are making use of the Leibniz test, okay, which is basically one of the tests for checking this condition. So the null hypothesis for the Leibniz test states that equal variance is assumed. The alternative states that equal variance not assumed. Okay, now if you look at the p-value of the p-value of the Leibniz test, right? For the null hypothesis, you can see that this one is 0.0000. So basically, if you have to compare this to the alpha level at 1% or 5%, it means that you are going to reject the null hypothesis, right? And conclude that equal variance is not assumed. So instead of relying on this test statistic and its corresponding p-value to make inference for the two sample t-test or the independent sample test, we are rather going to rely on this one, that's the equal variance not assumed. Use its test statistic with its corresponding p-value to rather make inference instead of relying on the first one, okay, because we are rejecting the null hypothesis, okay. So one thing that you have to note with regards to the t-test or the independent t-test is that in books, I think in books, one of the conditions states that the sample size must be less than 30, right? But one thing that you have to note with regards to a t-test or the two sample t-test is that it is a symmetric distribution or a family of curves based on the concept of degrees of freedom, okay? And this is related to the sample size. So as the sample size increases, the t-distribution approaches the standard normal distribution, okay? And this is in relation to the central limit theorem. So even as we have sample size that are more than 30, we can still make use of the two sample t-test or the independent sample test, okay? So in here, we want to look at the p-value for the test for equality of means. If we are to compare this p-value to the alpha level at 1% or 5%, it means that we are going to reject the null hypothesis and conclude that the distribution, the mean value of the sepal length for C2 and that of Beninic are not the same. Okay, that's one way to interpret it. Another way to interpret it is to state that say that the difference in the mean value, or let me put it in this way, there's enough evidence to indicate that the difference in the mean value of the sepal length for Setosa and that of Virginica is significantly different from 0. Okay, that's another way to interpret it. Okay, so I think we are good to go now. Now let's assume that the normality assumption failed, the test for normality failed. Then it means that we are supposed to rely on the non-parametric test and make use of the Mann-Whitney U test or the Wilcoxon Rank Sum test. Okay, so let's go back to our window editor. Let's assume that the normality test failed. So we are going to rely on the non-parametric test, okay, and make use of the Mann-Whitney U test. So let's go to Analyze, scroll down to non-parametric test, scroll down to, there are two ways to do this. You can choose this, right, or go to Legacy Dialogs. I'm going to use this type and scroll down to two independent samples. So let's click on this. So in here, I'm going to drop this variable inside this test variable list, okay, and the species 1 should come under the grouping variable, okay. So let's define the groups. So 1 is for Setosa and 3 is for Virginica, okay. Continue. So already Mann-Whitney has been checked, so we can proceed, okay. Alright, so we can see that here's the result. And one thing that you also have to note with regards to the non-parametric test or the Mann-Whitney U test is that it requires that the sample size be smaller, let's say less than 30, but we are going to skip that for now, okay. So let's look at the p-value from the Mann-Whitney U test. If you look at this p-value, if you have to compare it to the alpha level at 1% or 5%, it means that we are going to reject the null hypothesis and conclude that the median value of the sepal length for C2 and that of Virginica are not the same. In other words, we can also say that there's enough evidence to indicate that the difference in the median value of the sepal length for C2 and that of Virginica is significantly different from 0, okay? Alright, so I think we are good to go. So this is basically how to perform a detailed statistical analysis for two sample data in SPSS. Please, if you find value in today's tutorial video, don't forget to subscribe if you have not, and also turn on the notification bell to get more updates anytime I post on this channel. Thank you for watching.